Thank you guys for coming. My name is Raj Pathak. I'm a Principal Solutions Architect in our Financial Services and Generative AI team. I was also part of the group that helped launch Amazon Bedrock. So we have a 20-minute session today. Really want to get into both the data security, how we manage data, how we manage transit networking, so like how does the network get access when you make a request, but also want to show you guys how to think about when you use Bedrock and you use generative AI on AWS, how do you protect your application level security as well? So think PII, PHI, kind of that more protected information. It is a lightning talk, so we have 20 minutes today. Going to go through this stuff pretty quickly, so if you do have questions, feel free to grab me over there in the corner after the session today. But to kick it off, we're just kind of level setting on what Bedrock is, what it does as a service, and then just how do we manage the underlying security, and then how to think about when you start building applications with Bedrock, how do you think about securing your prompts and those responses? So let's get into it. Just a show of hands, how many people have used Bedrock before in the past? All right, cool. Happy to hear that. So really think of Bedrock not as an LLM. Bedrock is not a large language model. Bedrock is not a generative AI model. It's a service that we've designed to help customers accelerate the development of generative AI applications. So whether it's using foundational models from providers that are leading in this space, or if you want to implement more generative AI patterns, think things like retrieval augmented generation, agents, we make that in a fully managed environment. So you don't manage servers, it's a serverless experience, and you do it through a single API. In the scenario where you want to fine-tune your models, you can bring your own data, give us a labeled list, and we'll fine-tune one of the base models on Bedrock to your specific use case. And we'll touch on that in a lot more detail. Not going to go over the extensive list, but these are the foundational models available today on Bedrock. So whatever your use case is, if it's image to text, image generation, modifying images, creating text, generating code, there's really a model for you. And depending on the vendor you may have already used today, it could be available here on Bedrock. But another thing we offer is different t-shirt sizes for those models. I work on this notion that if you can get something done faster and cheaper, why not? And we want to give our customers choice. What we've noticed is a majority of our customers on Bedrock today are actually using more than one foundational model provider. And we see that being a pattern. So we want to make that as easy as possible for customers as they get involved with generative AI. So let's get into the meat and bones of things. How does Amazon Bedrock manage security? You saw that large list of model providers on the last slide. You're not making external third-party API calls when you use those models. We've worked with these vendors to give us their model weights. And for those of you who aren't in the machine learning background, think of a model weight really as the artifact behind the model, the brain behind the model. They've given that to us as AWS, and we manage that as an AWS service. So everything you're used to with IAM, with your network controls, with your logging and monitoring, any sort of private network connectivity like private link, your KMS keys, that's all available. You're just using an AWS service. Nothing leaves the AWS ecosystem when you interface with the models. You can either use it through the console or an API, and it's all governed by those security controls you're familiar with. And to get a little deeper on how that actually works, because we host those weights, because we manage the actual models themselves, we have a lot of control on what happens with the prompts and the responses. By default, none of the customer's data, so your data is actually used to train the underlying foundational models, and none of it is passed to any of the model vendors. So all those providers you saw have no visibility into what you're prompting the models, along with what your responses are. So we want to make that very, very safe and secure. Just know that when you use Bedrock, your data is protected. And when we start thinking about encryption in transit and in rest, it's done with Amazon KMS. So it's encrypted in transit with TLS 1.2 minimum. And if you want to bring in your own customer managed keys, that's something you can do as well. We'll touch on fine-tuning in a lot more detail later, but really think about it as fine-tuned models are specific to you as a customer, and they're encrypted and stored with your customer KMS key. And just know that only you have access to that underlying customized model. Touched this before, but really, you have AWS IAM that's going to be your credential provider. So whether that's invoking the LLM, using it in an application, it's all done with those IAM constructs. And there's a lot of compliance support that you're used to with AWS services. So think GDPR, HIPAA, PCI, and most recently, FedRAMP Moderate. We do not log any information, but I recommend that you as a customer do log your prompts, you do log your requests, largely for auditability and also seeing what your end users are using these models for. So within Bedrock, there's a native integration to CloudWatch where you can log these things about your token consumption. What models are you using? How are they being used? What are the prompts and the responses? What's the inference latency? Just those metrics that are important to think about. And then from the CloudTrail side, hey, where are people using this API? How are they using the API? That's all logged within your AWS account if you enable this within Bedrock. Last but not least, those compliance frameworks exist. There's a large list you can check out on our website, but really think about it as, hey, SOC compliance, ISO compliance, HIPAA compliance, and then mention FedRAMP Moderate. And just to show an IAM permission, I'm not going to go too deep into this one, but really, you can get granular with how you vend these models. If you want to deny certain model vendors, you only want to allow certain model types, those IAM constructs around identity-based policies, policy resources, ABAC, principal permissions, those exist within Bedrock. But one thing we noticed talking with our customers is IAM isn't it. We want to make sure that we allow security engineers to get very granular with how they vend permissions. So IAM alone does not provide access to models. You have to enable model access through the Bedrock console. So you pick which model you want to enable. And Bedrock is a regional service. So everything stays within that region. So if you want to enable the Anthropic Claude model in US West 2, a user from US East 1 can't use it. So this way, if you have data sovereignty or compliance rules, you'd be very specific. And if the end user license agreement isn't something you agree with in a certain geography, but you do in another, just know that. And each of these models come with their own end user license agreement. So if you pass it off to your legal team, you can have them analyze it and make sure it's safe to use in your organization. So those are the basics. Let's actually get into a lot more detail on how we do the deployment and how it's managed behind the scenes. There's two types of model deployments within Bedrock. It's what we call the on-demand compute. So think of this as just the general API. When you invoke the Bedrock API, you use one of the foundational models on Bedrock, you're calling the on-demand compute. And it's a deployment that's available to all of our customers. The second is something called provision capacity compute. So this is a deployment that you're doing specifically for yourself. There are common features. Really think about it as, hey, we're never going to log any of those inference requests. It's never used to train any of these foundational models. All the deployments are happening within a Bedrock service account, and they're managed and operated by the Bedrock service team. And last but not least, again, we do not share any of this. No one has access to these models outside of AWS. Really, the way to think about it as on demand, it holds a baseline model. It's versioned. We manage it as an AWS service team. And with provision compute, really, it holds a private copy of that model that only you can invoke, only you can play with. And if you do fine-tune a model, you will have to use provision capacity because it is very specific to you. Think of this more as, hey, I'm hitting really large scale. I'm hitting very large throughput. My token consumption is very high. Think of it more of that way. You're still getting all those same similarity protections that we talked about. So let's actually walk through when you make an API call to Bedrock, what's going on. Talked about it. Let's start with the similar construct that we're all used to. We're in an AWS region. We have a VPC, and we have a client within that VPC. We may also have our local network, and we're invoking the API through our local network. A simple network path is probably just going to be via a NAT gateway, an internet gateway interfacing with the Bedrock API endpoint. Or locally, hey, we might just be going through the public internet. This is probably how most folks are going to interact with Bedrock. But in a scenario where we need a lot more granular security, where we need to have things traverse through the private network opposed to the public internet, going through something like Direct Connect, interfacing into our VPC, and then connecting with AWS Private Link, and then using VPC endpoints to actually make that call. That way you're traversing through the AWS backbone, and nothing goes over the public internet. VPC Private Link support is supported within Bedrock natively. So if this is a pattern you want to employ, just to stay a little more secure. So now that we've connected, let's see what's going on behind the curtains. How have we actually deployed the Bedrock service? There's two different accounts when you start to use Bedrock. The first one is where we run our runtime inference. So we're actually making those inference commands, how we're determining which model to use. Think of this really as the front end into the models themselves. You make your API call. We determine the model you're trying to use. Make sure you have the correct permissions. Do you have the right logging? Do you need to log this information? And do we need to write that to your account? Kind of all those security paradigms that you're used to. After we determine that, each of the models has their own respective model deployment account. And if you're invoking it with the on-demand compute, you're now going to hit that on-demand model architecture. We're going to send you that response back. And this is just really a generic flow. The way that changes with provision capacity is a little different. You have a runtime inference, same thing happens. But instead, you're going to pass a specific model ID. So all provision capacity models have their own specific model ID. Or for a fine-tuned model, you're going to pass a specific ARN. That's then going to hit that specific model capacity endpoint for provisioned capacity, pull in that tuned model or pull in that base model, and make those API calls. So now I'm going to touch on fine-tuning. Fine-tuning is really unique within AWS because we actually don't write back to your customer accounts. And data never actually leaves your network controls. We're very specific with how we want to protect your data. So let's just say you've now triggered a command. You want to invoke training orchestration. What this is going to do is it's going to trigger a SageMaker training job from within the relevant model deployment account. This takes a base model from its S3 bucket, and then it's going to reach out to your customer S3 bucket. This is where all your training data is going to be. We're going to create a fine-tuning job, and what this is going to do is this is going to take those VPC network controls you tell us. Hey, I want to define what subnets I want you to train this on. I want you to tell me what security groups to use. Once you do that, we're going to place an ENI within your VPC as specified, and then we're going to route the S3 commands through that ENI. That way, it's going to adhere to your network controls that you tell us. And from there, we'll train the model, do the model fine-tuning, and we're actually going to write the artifact to a fine-tuned model bucket within the model deployment account. We're never going to write information back into your S3 bucket. It is simply a read command. There's no writes going on there. So I know that was quick. It was really fast, but I wanted to make sure that we understand how Bedrock is being invoked and what's going on in the backend. It is a fully managed service, so when you make this command, you're not actually telling us how much server capacity you need. You're really giving us the correct IAM permissions, making sure you've enabled that model within the model access. And once you've configured that, you tell us, hey, do I need to make a just general on-demand request or through provision capacity? And we'll take it from there. And now I want to get into a topic that I think is a little more important as you start to build on Bedrock. And that's really securing your prompts and your responses. We're seeing more and more of our customers run into some challenges where, hey, we understand that using these things will protect our data, but now from an application standpoint, people may be prompting our models with something we don't want to prompt them with. Or we're using really regulated information. Think PII, PHI, sensitive information where it's important for inference, but it's something that we don't want to have exposed. And this is a common topic, right? Hey, I don't want to talk about my competitors. I don't want to talk about topics that aren't relevant to my underlying application. This may be controversial, too. You don't want to be on the news for something that may be different. So we noticed this became a really big problem for our customers. We also noticed that, hey, we don't want to be attacked, right? Prompt injections, prompt attacks, comments to manipulate the model or red team the model are very common. So how do we prevent that? And then last but not least, we touched on this earlier, but how do we protect our user data and how do we do it in a managed way? And how do we enforce this across the organization? How do we make it a simple call so every API call to Bedrock has this information in there? And last but not least, how do we do this across the different model vendors? You can do this within the prompts themselves, and a lot of the vendors have tuned their models to manage for a lot of this stuff, but can be inconsistent, but also you want to make something that's very organization specific. That's where we're happy to announce Guardrails for Amazon Bedrock. And the idea behind Guardrails for Amazon Bedrock is, in very natural language, how do we tell the underlying foundation models, you should not do this? And instead of having this logic baked into our prompts or baked into the models, which are more probabilistic, how do we do this as a filter before the prompt even gets to the models? And how do we check after the model gives us a response? So there's multiple components of a guardrail, and we'll touch on that in a little more detail right after. But think about it as, I do not want to talk about this topic. I don't want it to take in this type of information. If you see these types of words or phrases, just default to a structured response. And all this is done with natural language. So now this is programmatic model building. This is all pre-trained models that you just specify in very simple language on what you'd want the model not to do. So how does it work? We'll walk through this architecture pretty straightforward. Someone will prompt an LLM on Bedrock, and you're not invoking a new API. It's just a parameter you pass to your Bedrock API. From here, we'll trigger a guardrail. Guardrails have different components. Think of denied topics as really just a flat-out deny. I don't want the LLM to talk about this. I like to use the use case of a doctor's office building a booking assistant. You don't want it to give you medical advice, or a financial firm doesn't want it to give it fiduciary advice. I just don't want them to talk about this. Very simple language, and then you tell it some sample phrases. From there, there's content filters. These are filters that we've built here at AWS that we think adhere to kind of what we call responsible AI pillars. This could be things around racism, sexism, but some more LLM-specific things like prompt injections, prompt attacks, or criminal or misconduct type activities. You can specify the filter strength. So if you want these to be very strong, you can do that. Or if you want them to be, I'm okay with this slipping through. I don't want this to be too tough. You can set that lower as well. The third one is probably the one I think is most relevant, and this is sensitive information. You have two options. We've built a list of 34 PII entities that you can either mask or block. So if you want to just block it and just not have the model respond, you can do that. Or if you need it to mask the input, so they'll point to things like your first name, your last name, your credit card information, phone number, social security number, health card number, health insurance number, whatever it may be, it'll mask that. You can also specify custom sensitive information using things like regex. So if you have organization-specific custom information, provide a regex pattern, and we'll do that matching for you. And the last one is word filters. So if you have certain words or phrases, think names of competitors, think words you just don't want your model to adhere to. Or there's profanity. You specify that within the word filter, or use the pre-built profanity checker. And then from there, if we intercept that, we don't even send it to the model for inference. We give you a final response that says, hey, I can't answer this. Or in the scenario where your prompt passes the guardrail, it'll then be passed to the LLM for inference, and then we'll do the same check on the response. We'll see, okay, does the response pass our guardrail? In the event that it does, we'll just let you do a normal LLM call like you're used to, or in the event that either the prompt or the response triggered the guardrail, we'll give you a canned response. It's just a good way to think about, as you start to build generative AI applications, infrastructure is really important, and the way you invoke models is really important around data privacy, network controls. But just as important is the way you've configured these security controls at the application level. So making sure your models don't respond with toxic behavior. It's something that would kind of account for a risk. So appreciate everybody taking the time out today. We have a ton of great code samples for almost everything that you saw here today. So definitely check those out. We have a great workshop. It's all open source code. And if you want to keep up to date with just all the cool launches that we're having here at Bedrock, I would highly suggest checking out the Bedrock blog. So I want to thank everybody for their time. Please do fill out the session survey. And if you have any questions, I'll be right over there and available to chat. Thank you all so much.